So today, and for our friends stuck at home sick, there's the homework. Toolkit. I was chatting with somebody, and they were like, I'm trying to figure out if I still need my toolkit in my binder. May I borrow this? Thank you very much. Yeah, if you said no, I would have. So your toolkit is still most definitely useful. Notice it's got examples of using the 5D process. It's got examples of solving equations and combining like terms exactly like we've been doing. It's got examples, flip back, probability of multiple events. It tells you what consecutive integers means, because that word gets thrown around. It shows you part-to-whole visualizations. This is still really useful. So I'm not requiring that you guys take notes in it anymore, because most of us were filling it up fairly fast, and then we were like having to switch, and our notes were in 2 different places. But realize that as you do your homework, that's a resource for you. And it's a really nice, lightweight, easy-to-use paper resource. So it's still most definitely useful. So today, we are talking about cases with infinitely many solutions. All of them, or none, like can't happen. So can you think of a situation that doesn't have a solution? Like they'll never be the same number at the same time. Grant? I mean, that is impossible, or it's 1, we're not quite sure. But not quite what we're talking. We're talking about like a relationship between 2 things where they can never be equal. Like, I know one that has involved me ever since the day I was born. Because I have siblings. Allie? Ooh, yeah, so the relationship between me and my siblings, if my sister is 2.5 years older than me, which she is, and my brother is 6 years older than me, we're never gonna be the same age at the same time. It just can't happen, right? We can't, like, plan out sometime in the future where we'll be the same age. That doesn't work. So if your brother is a year older than you are, that's like x for you, and they are x plus 1. And that will always be x and x plus 1, but they'll never be equal, right? It just can't happen. So, in this lesson, we are going to practice strategies for combining like terms, removing zeros, balancing, to simplify, and compare it to expressions. So, by the way, right here was a reference of ages not being able to be equal. Oh, Annika! You're in this problem, by the way. You're in this lesson. You're so happy about it. Do you have a brother named William? I know you don't.
I do.
You have a brother named William? Does he go by Will? Is he younger or older?
He's almost 19.
He's almost 19. So will you guys ever be the same age at the same time?
Yeah.
So that is an unsolvable. You're like, that will never be equal. So, think about these questions as we go through the lesson. So what if both sides aren't actually equal? What, Delaney, if the problem lied to you from the get-go? Is essentially what we're saying. Like, what if the 2 sides are actually not equal? Are there multiple values of x, or many, that could actually make this true? And do situations always have to have a solution? So, if I go to the store, and I want to spend $10, but apples are $3 a piece, can I buy just apples and spend my $10? If I buy 1, I'll spend 3. If I buy 2, I'll spend. If I buy 3, I'll spend. If I buy 4, I'll spend. I can't make 10. Unless I can buy a partial apple, but I doubt it. Right? The store's not going to let me do that. So, I'll just read this for a second. So many students believe that every equation has to be solvable. However, in the intro, like we talked about with ages, and I'm just going to go rogue from this a little bit, hopefully you're starting to believe me that that's not true. We cannot always make things equal. So, for some equations, and all the equations we've dealt with so far, they have what we call one solution. So the solution, we've mainly been working with values of x. The solution is the value that makes something true, right? Left side equal to right side, or left side equal to 17, or whatever we're dealing with. If it's never possible, my age equal to my sister's age, it's just not going to happen, we say no solution. Please, in your notes, jot down no solution with the symbol, or you can put the symbol first, a 0 with a slash through it, kind of like what you see with the no smoking signs or things like that. A 0 with a slash through it means empty set or no solution. So if you want to represent no solution, all you have to do is put that symbol. And then we have a really cool symbol for when all numbers are solutions. So when the solution, and in your notes, we can just go ahead and write like every number or any value of x. So when any value is a solution, we call this all real numbers. And some of your friends in Mr. Hall's math have been working with this a little bit. Sorry, I ran out of board space. That's a super easy symbol too. So I'm only going to ask you guys to write these words one time. That symbol is an R with two verticals. Fancy pants R. So why we use that symbol is it's all real numbers. Now you don't have to worry about what numbers aren't real. You'll get there. Kind of like don't open that box yet sort of thing. But there are numbers that aren't real. Don't worry about that yet. But this means any number you put in 3, 7, -4, 8.16, 3,846, like any number, that's real. Questions on those symbols? The empty set symbol, by the way, jot down here just so you know the name of it. Please put empty set because that's its technical name. That symbol is the empty set symbol. Yeah, Grant?
Is 0 a real number?
0 is a real number. So that's not 0. That's a symbol.
Right.
Right. But it's a number. It's a quantity. It's an amount of something. You currently have 0 pizzas, and that's real. So I need you, with your partner, if you choose, to work through A through H and decide, does this have one solution? If so, you can try to figure it out. Does it have no solutions, like it's not solvable? Or does any number work? And then it's all real numbers. Please, in your notes, jot down the equation and then put whether it has one solution, or you can use no solution, empty set, or you can use all real numbers, the fancy R. I'll give you a couple minutes for this. So there could be one solution, or none, or any number. So there's 3 options. No, there's no, because then we would just say X is whatever. Hey, so Francesca just asked a really good question. She said, is there a symbol for like the one solution? No, because we would just say the answer. Like the symbol is stating what that one solution is. So is there a situation up here where you can tell me it has one solution and you can tell me what it is? Patrick? B, you think it has one solution? What is it then? 2. So 2 plus 1 equals 2? So you're saying...
no, my bad, no. Oh, I was looking at it the opposite way. I meant D.
D. So D, Patrick is saying if I plug in a 2 for every x, so 2 plus 2 equals 2 plus... That's true. So what I put for D is just x equals 2. And we could have found the solution through the process. Gonna use some cards so we can kind of get comfortable with this. Marvin, when you look at A, what do you think about that? X equals X. Do you think that only has one number that makes that true, no numbers that make that true, or any number? Any number? Because if I plug in a 5 for my x's, 5 equals 5. I plug in -17. -17 equals negative. This will always be true, so we use the fancy R. And x is equal to x. Nathan, what about x plus 1 equal to x? So imagine you have a sister, brother, whoever that is 1 year older than you. Will their age equal your age? No, this doesn't make sense, right? A number plus 1 equals the original number? No, that's not true. So we use the empty set. That was a lie from the get-go. That equation was not true. Grant, what about C? X equals 2x. I argue that there is a C. So if we work bounds pairs, think of Ella. Everybody write this in your notes. X equals 2x. Make sure you have that written down if you haven't done it yet. Think about this on an equation map. You have an x over here, two x's over here, so xx. Anyone have an idea of what I want to do? Kate?
I have an answer.
What's the answer? Because if you take away an x from both sides, you get 0 equals 1x. So if I plug in 0 equal to 2 times 0, that's true. And that's the only number that makes this true. It's a real number, right? 0 is a value. So that actually has the answer of x equal to 0. It has one solution. What E? Patrick, what do you think? X plus x equal to x minus x.
I think one solution.
What is it? 0 plus 0 equals 0 minus 0?
Oh.
Does that make sense? Yeah, they both come out to be 0, right? Will any other number make sense? 2 plus 2 equals 2 minus 2? That doesn't make any sense at all. So x could be 0. That's a really weird one, but it does have one. So please be careful. When we're writing empty set, it's not x equals, you just put empty set. When the answer is 0, you put x equals 0. Questions? What about f? X plus x equals 2x. Liam? Is x2 like the solution could be 2? 2 plus 2, does that equal 2 times 2? Sure. What if I try to solve this, right? I haven't solved it. Alex, do you have an idea for how I could solve this? Take away an x from both sides. So if I have 2x minus an x, that leaves me with an x. If I had x plus x, but I take away an x, I still have 1x. If I have x equal to x, I agree that 2 will work.
Wait, so any number?
But so will any number. That is all real number solution. Because guys, a number plus itself equals 2 times that number? Yes, always. Like, that's always going to be true. Think about G, Francesca. If we have x times x equals x squared, is that only true once? Is it never true, or is it always true? So think, I mean, that you have a question mark on it, so try it out. 2 times 2 equals 2 squared. Well, what does squaring mean? Squaring means a number times itself. This is always true. It's essentially defining squaring for you guys. That's a really good one to have in your notes just to remind you what squaring is. Please make sure you're working along with me. What about x minus 1 equals x? Will your little brother, who's a year younger than you, ever be the same age as you? No, this doesn't make sense. No x equals, we just put an empty set. Now you can also write the words no solution if you really want to write, or if you're writing a sentence or something like that, you'd say there are no solutions to this function set. Questions on how we're looking at these situations, how we determine their solutions? Try this. I'm not even going to read it, just try this out. Emma, if we were to try to talk about how old a brother in this situation is, how do we write an expression for how old one of the brothers would be? Who's older, Kelly or the brothers?
The brothers.
Brother, by how much?
6.
Each of them is 6 older, right? So if we were trying to set the brother's age, we could say, how do we say Kelly plus 6? So we could say K equals B minus 6, right? The brother's age take away 6. Or we could say the brother's age is Kelly plus 6, right? Either of these would work. It all depends what route you want to go. Okay. Man, this equation that we have is kind of complicated. How old will Kelly be? So wait, if it's asking, how old will Kelly be, what are we trying to solve for? If it's asking how old, what? Yeah, what if we represented that with? K, so we want to solve for K. So do we want to use the B expression or do we want to use the K expression? Use the one with K. So we're going to use this because that's what it wants us to solve. If that's a brother's age, they're twins. Did not mean to do that. This is tough to write. Does anyone have a guess?
Please excuse this interruption. Could Colin Williams please come to my office? Come to the office, please. Colin Williams.
What does is mean in a mathematical equation? Something is, right? Grant is. Annika is. Alex? Equals. Right? You're describing what something equals. So that's my equal sign. How could we write the sum of the brother's age? Right? Marvin?
Bro, B equals K times 2.
I don't want to use two variables. How could I just write the sum of the brother's age? Okay. But you gave me two variables. You use B and K. You can't use two, you can only use K. So I wrote this, but we don't want to use that one, right? We want to use this one. Each brother's age is K plus 6. You might, okay, I'll come back to you. You look very upset. How do you add up the ages of twins? And that you could do for any kids, right? But they're twins, so it's actually easier. Multiply by 2. So we could add them together, or we could multiply by 2. So both brothers' ages, the sum of her brother's ages, could be represented by 2 times what? What are we using for the brothers' ages? We don't know how old they are right now. Ignore the 12. We're not on the right side yet. Remember, the is the equals. We're not over there yet. Ella? This is the brother's age, right? K plus 6. That's the brother's age. That's your left side. Both of the brothers' ages. Please make sure you have that down. How do I write 12 more than Kelly's age? Marvin had a hand up there. Marvin, I didn't know you were a ventriloquist. You throw your voice. K plus 12. 12 more than Kelly's age. With your partner or whoever's close to you, solve this equation. So guys, we are trying to work to the point where the 5D process is unnecessary. I love that a lot of you guys set it up, and I know it says use the 5D, but if you can avoid it, you don't have to use it. So if you want to use it, you can try. You can try to solve it that way, but that's why I wanted to make sure we set up an equation before I gave you time. If you can avoid the 5D, equations are better. Is anybody going to catch this? Caitlin? I know. Well, I'll come to you in a second. Alex?
It's supposed to be 2K plus 12.
Hey, people. I occasionally drop one of these as like bait, seeing who's going to pick it up. Now give me your attention for a second. If you started trying to solve what I had written here, you get 2K plus 12 equal to k plus 12. This cannot be true. So all you had to do is distribute to hit a point where you're like, wait a minute. 12 more than twice Kelly's age, which, guys, was up here, was in your book. You were all staring at it, yet you let me write k plus 12. It's not k plus 12. What should this be? 2k plus 12. So, wait, after my distribution, please make sure you fix that in your notes. No. When you catch those, that's worth candy. So wait, I have 2k plus 12 equal to 2k plus 12. Interesting. What does that mean? I have the same expression on the left side and the right side. Liam?
It could be any number.
Any age. Her brothers, because they're each 6 years older than her, this relationship always exists. Them added up is 12 more than twice her. Think about it. There's 2 of them, and they each are 6 years older. Put them together, I need 2 of me, if I'm Kelly, and then 12 years. It makes sense when we think about it that always happens. But that's a weird idea to get used to, right? That literally X is any number here. Any age. Now, we can't have negative ages, but according to the math, it would work. Right? The math would let it happen, although you can't be a negative age, the math would let it happen. Does that answer what you were asked about? So be careful with this distribution. One of the biggest mistakes I'm seeing, guys, this second arrow. The second arrow that goes to the 6 in this case, people keep forgetting to do that multiplication. So you multiply the 2 times the k, but you also multiply the 2 times the 6. Please check your work on this, make sure it's good. Questions? All right, special cases. So, I think we're beyond using equations math, because most of the time nobody wants to grab them. But if you want to use it, Algebra Tile is always here accessible to you. Or set this up on your paper. So if we're going to do the algebra, you got to write out the original equation. So I'm going to show the algebra up here.
In the second part, why is the parentheses around -4?
Because it's the first number that happens. So they could have said x plus 7 minus 4, right? Because that could be thought of as a -4, but you can't minus from nothing.
I thought once an equation starts with a new number, it doesn't have to.
It doesn't have to, but it's nice. Because saying -4 at that point would be wrong. In certain formats of doing math, a negative, you always put a negative in parentheses. So if we're going to call it -4, some people would say, oh, it has to go in parentheses. Not that mathematically that's a rule, but it's just nicer. Negative numbers should really be in parentheses. Not that it would make it right or wrong, but... What can I do? Aubrey, what can I do to start this thing out? She probably knew that. Matt, what do you think? What can I do to start this thing out? What do you mean get rid of? So you're ahead of us. You're too far down the process. Back yourself up a little bit. Look on the left side independently or the right side independently. Is there anything that needs done? Alan?
Compare like or combine like.
Combine like terms! Always look for those values that can go together. 8 can go with -5, right? What's an 8 with a -5? 3 So now we have 3 plus x. What about over here? Negative 4 and 7, right? What's that give us? 3. Wait. Would this work if I plugged in 0 for x? Would this work if I plugged in negative 5?
Yeah.
What about 10? What about 8,472,000,000?
Yep.
Peachy? Why? It's the same thing, right? Even though they don't start identical, like we can't really say the start was the same thing, but once we simplified, these are the same thing. So what's my answer here? All real numbers. Fancy pants are. He has 3 legs, apparently. Or these could just be his 2 legs, I guess.
Yeah.
And this is like a cane.
Yeah.
That was like me with my crutch.
Not like a walker.
That was like me with my crutch.
Fancy jazz, and a top hat. So. Questions on that, by the way? Gravity works. Questions on this one? Try this guy. Try this guy. X plus 2. Oh, supposedly you got on schedule 1. I trust Mrs. Golden. This is traumatic. Anybody still have it in your binder?
I mean, I memorized it.
The original one? Sorry. I didn't know we were going to go backwards. We normally only move forwards. Do you have answers for this? Because I'm using cards. And I think we're all aware of that now. X plus 2.
Yeah, it's at 6.
Always look for like terms.
We kind of like
Monica, what can I do here? There's not a 2 on each side. Wait. Ah, the x's, right? So these can combine, and we get 2x plus 2 equals 2x. Eleanor, what's that mean? Will double a number ever equal double that number plus 2 more? No! This was a lie from the get-go. So these sort of situations, these no solution situations, say you're modeling the revenue, get like money coming in, and cost of manufacturing. And say you were trying to model these using equations or graphs or anything like that. If you know that you start with cost being higher than your revenue, like what you bring in, if we think about this graphically, imagine that this is time, and this is money, out versus in, right? Well, we have to spend versus what's coming in. If I start here, because you'll normally start spending more. Sorry, that should be a straight line. Then my money coming in, you normally don't make that much when you start. You got to build popularity, build that clientele base. You're hoping that at some point these equal, it's supposed to be straight, but don't worry about it, and then surpass. Now, if you find out that there's no solution, that means that they never cross. And your in never passes your out. And in an even worse situation, if they cross back here, that you can't go back in time, you can't get there, that would mean that this line's actually going down, which would be really bad. So, this is what we're actually looking at. Like, what we're getting to is understanding, when will my expenses equal my income? Will it ever happen? Or situations that are always the same, which those are even kind of weirder. So, we've got a little over 5 minutes. I want to give you at least 3 minutes to work through these, see if any of these confuse you. I want to take questions on, like, as you hit some of these, you're like, wait a minute. So write these out from the beginning, try to solve them, find out what x equals, or is it none or all? If I were you, I would give yourself space vertically to solve these. So in A, what could we do to both sides to work the solution? Emily, what could I do in A? Yeah, we can use balance pairs, and we can do what? That, I'm kind of out of space, I'm going to jump, gives me negative x equals 2. So what does that tell me x has to be? The opposite of 2, right? Because the opposite of x is positive 2, so x has to be negative 2. Please have this written down. So, if I see the couple faces. If I have negative x and I want positive, we can just multiply by negative 1. Nathan, could you write this down for me, bud, since you don't have it on your paper yet? That's how we get to positive x. Because multiplying by 1 does nothing. Multiplying by a negative 1 flips your sign. It's negative makes it positive. It's positive makes it negative. And B. What do we do first? Renaud? What do we do in B? What's the first thing you do when you look at that? I can't do that yet. We have a number right up against parentheses, which tells me to do something. Yeah, we got to distribute. So the 2 comes to the x and to the 3. I'm going to jump again here. So negative 3 plus x equals 2x plus 6. What was that, Alex? Well, we did distribute the 2. So then what do we do? So we got the 6 from 2 times 3. Are you looking at B with me? Or are you looking at me? So that's where our 6 came from. So now I've got negative 3 plus x equal to 2x plus 6. Penelope, what do I do? What do I do? Okay, what balance pair? Just tell me what to do. I don't. There's 4 options here, really. You said you want to take care of the negative 3. What makes negative 3 into 0? Hey, we're not done. So I don't care that they released. I don't care that they're packing up. We're going to finish this problem. Right, Rob? We're going to finish this problem. We're not done yet. So we add 3 to turn that into 0. Then left side is just x equals 2x plus 9. Since my numbers are over here, I want to get my x's over there. How do I get my x's over there? You can tell me. You can take anybody. Alex? Take away the 2x. Unless you ladies are telling me how to solve the problem, I don't think we should be talking. That gives us negative x equal to 9, which actually means x has to be negative 9. Make both the opposite. Now we're done. Thank you guys very much. Again, Math Journal Check Friday with our mastery, so please make sure you are caught up and doing your homework. Thank you very much.